Assalamu alaikum, dear students. The topic which I am going to discuss right now is the sound. It's very important in physics. You well have heard about this. So we will quickly go through the basics of sound and then we will discover some important facts about sound. So let's start. So it is very important to know about the sound. What actually sound is? Sound is basically a series of the waves that is going to caused by the vibration. So it means that it is generally caused by some vibrations in some materials bodies. So what are the types of vibration we will going to overthrow over it? So you will have the well familiar example of this sound, how sound is going to be produced or how sound is going to be generated. You may get the enough idea by showing it, like when, like we can give it an example, like when drum is going to be struck, then the surface of the drum is going to be vibrate backwards and forwards very quickly. So we will get finally the sound waves that is going to propagate through the ears, propagate through the air, and it is going to listen by some listener or by some ears. Okay, so fine. This is the example of sound, how the sound is going to be generated. Next, we know that sound wave is going to travel as a series of compressions and rarefactions. What are the compressions and rarefactions? These are the high dense areas. These are called to be compressions, and rarefactions are considered to be the less dense areas that is going to be propagated through the air, and these are in longitudinal in nature. Fine. So here you can get the final idea about the longitudinal wave when the source is going to move left and right. So basically the direction of propagation of wave is along the disturbance in which you are going to propagate your wave. So if it is the coil, then coil is going to move left and right. So we are going to transport energy from one point to another point. So this is basically the type of wave in which the disturbance is along the direction of propagation of your sound waves. So here is the idea of this physics classroom. Longitudinal wave, you can also go through this. So for example, sound wave is basically the longitudinal wave. So I have already discussed that compressions are the highly dense areas. This is the example of the coil that is going to produce some longitudinal waves. So these are the regions where you can see the density is greater, and these are the areas, these are the regions where the density is very, very low. So rarefactions are the low dense areas and compressions are the high dense areas. So this is again there are the sound waves are basically the series of compressions and rarefactions. So these are the vibrations that are going to be propagated in your longitudinal waves, and sound is best example of it. So longitudinal waves always propagate in the direction of travel. So sound waves in this sense are called to be longitudinal waves. And there are many examples in which the sound waves can be generated. For example, the Scottish pipe, the piano, the drumsticks, and guitar, and there are many other examples by which we can have an idea about sound waves. So, what are the key factors about sound waves? First important factor that should be noticed is that sound waves are longitudinal waves. The second factor that sound waves always need some medium in which they are going to propagate. So we always need some medium in which the light, in which sound waves are going to travel. If you have not any material, so sound waves are not going to propagate in that empty space. So you can say that there is always a material like waves. Sound waves are considered to be mechanical waves in this sense. Very important factor that sound waves can travel through solid, liquid, and gases, as already we have discussed that sound waves need some material to travel. So these are the three types of the materials: solids, liquid, and gases. So we can conclude like this: sound waves don't propagate in your vacuum or in empty space. What are the speed of the sound in which they are going to travel? In 1 second, sound wave is going to travel 330 meters, or it can be reformalized like 760 miles per hour. So you can see that if light is going to propagate 3 into 10 by 8 meter in 1 second, so how much less the speed of sound distance. So this is the speed of sound at 0 degrees Celsius. This is the example as whenever the lightning is going to be flash in some thunderstorm, so lightning travels much faster than the sound of thunder. So this is the basically the difference in that particular lightning flash. So what are the speed of sound? Speed of sound basically depends upon the temperature of the air. If temperature is going to be raised, then sound is going to be travel faster than, and if temperature is to be cold, so sound is going to be slower in its speed. So it means that sound is going to be travel faster in hot air as compared to cold air. So it doesn't have any effect on the pressure of the air, whether the pressure is going to be high or low. And third, it is different in different materials, faster through solid than liquid than gases, because solids have very dense packed materials. So energy is easily transferred in that dense packed material as compared to liquid, in which the density of the atoms is very less as compared to solid. Gases, the atoms are very far away from each other. So we can say that in solids, sound is going to be travel with highest speed and as compared to liquid as compared to gases. So how are you going to calculate the speed of sound in air? Speed is basically the ratio of the distance and time. And if you clap on one side and there is wall on the other side, so your clap sound is going to travel 75 meters. So when you clap, and if you have listener here over here, so basically the sound is going to travel the double of the distance between the source and the reflecting surface. Then it comes back. So distance would be 2 times of 75 meters because your listener is over here. If your listener is over here, so you have only 75 meter distance. So this is example where your listener is over this side, over the clapping side. So time that is going to be shown by your clock is 0.45 second. So you just put on all the values in this formula, so you will get the speed. That is about 333 meter per second. That is very close to the speed of sound. That is to be recorded in 0 degrees Celsius temperature, and that is the default value of the speed. Thank you so much for this lecture, and if you find any difficulty in this lecture, then comment below so that we can come back.